Good morning, good afternoon, or good evening, whichever is applicable to you, and thank you for joining us for today's webinar titled Catalog Data, Keys to the Kingdom. The ZOS catalog is the backbone of dataset management, serving as a central source of truth for where data resides and how it's defined. Each catalog entry holds vital details, such as dataset location, encryption key labels, data formats, and expiration dates, that help ensure security, efficiency, and compliance. In this webinar, we'll break down how the catalog works, what information it maintains, and what catalog entries look like in practice. We'll go over the tools available to search and display catalog data, techniques for extracting key information, and how to quickly retrieve dataset names, volumes, and attributes using REXX execs, giving you practical skills to streamline your catalog operations. This presentation is sponsored by Precisely Software. Precisely is a recognized global leader in enterprise data integrity products for mainframe, mid-range, and distributed systems. For more information on Precisely, please visit precisely.com. Our speaker today is Principal Technology Architect Steve Pryor. Steve has more than 30 years' experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining Precisely, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of the presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time during the webinar through the Q&A interface. If you encounter an issue where the slides do not show up or they're not advancing, please refresh your browser. After the webinar, all registrants will receive a link to the slide deck and recording. Thank you again for joining us today. Take it away, Steve.
Thanks, Ray. Good morning, everyone. My name's Steve Pryor, and this is the continuation of the DTS webinar series, now as part of Precisely. And so our slides are a little more purple, but what we're trying to do is give you some introduction to interesting ZOS topics, and particularly for users that are new to ZOS, because ZOS is really something quite different from the open systems environment. And at the same time, we hope we can come up with some tricks and tips and things you may not have heard of, even if you've got many years of ZOS experience. So today, what I want to talk about is catalogs, ZOS catalogs. And the catalog is a structure, is a piece of data that's really unique to the ZOS environment. You don't really, there are lots of metadata repositories where things are kept track of, but the idea of the catalog, which keeps track really of every file in a ZOS system and possibly in multiple ZOS systems, is really unique. And it's the place where if you don't have the catalog, you have chaos, and which of course is what we had back in the 60s and 70s. And the ZOS catalog really is something that is unique to ZOS and new. But actually, it's not all that new. If you've been around as long as I have, then certainly you're familiar with catalogs. You're familiar with card catalogs. This little picture there, of course, is what one learned in 7th and 8th grade of how to find a book in the vast library that you had, and a lot of training in those days revolved around how to find a book in a library. There were 3 different index cards for each book to find it in several different ways. And of course, we can extend that metaphor now to ZOS. Catalogs store metadata, data about data. Where is my data set primarily? When you're talking about a ZOS catalog, primarily you're talking about, I've got a data set name. I know what data set I want to deal with. Where is it? And what does it look like? And all of that is available in the catalog. It may, in fact, that some of that information, where it resides, the volumes it resides on, where exactly on those volumes it resides, is actually duplicated in several different places. And the catalog itself is a little bit complex structure because there are a couple of pieces to it. And so what I want to do today is talk a little bit about the catalog. What does it store? So there's things like the owner name, if there's an owner for the data set. Most importantly, aliases and pointers to other catalogs, because the catalog, when we speak of the catalog, we're typically talking about the master catalog and all its associated user catalogs. But what we really want to get out of the catalog usually is, given a data set name, what volume does it reside on, so that I can code a DD statement like this one, DD1, data set name equals my data set and disposition, whatever my disposition is. And I can code two
Steve?
things. Now,
actually, we are running into the issue again where slides are not showing. So if you could go ahead and minimize the attendee list and then share your browser screen.
Oh, okay. Let's see. Okay, I'll share. I'll minimize that stuff, and I could share the screen, but I'm not sure whether that's what we want to do. Let me share it for a second.
Yeah, I think that's going to be the only solution. Maybe that'll kick it in for some people. They're not seeing the actual slides where they normally show up.
Let me share that. And how does that look now?
All right, I see a shared screen. I think that should be good.
All right. Well, I'm just going to keep going with this, so everybody can now see my 1970s card catalog, I hope.
Yep. Yeah. Any other issues, please let us know.
Okay. So ultimately, what we want is to be able to code a DD statement like this one, data set name and disposition and nothing else. And the other information that we need to read or write the data set, we can get from the catalog. So we don't need to know everything there is to know. If I'm creating a new data set, I may have to add a whole bunch of other things here. What volume do I want it on? What's its logical record length? What's its block size? What's its data class name, and so on. But for an existing data set, once it is cataloged, hopefully all I really need to have to get to that data set is the name. Okay, so the catalog, as we said, stores metadata, allows us to locate the data set by just the name. We don't need to know the vol serial, we don't need to know the unit name, we don't even need to know if it's tape or disk. So it's a central place to keep all the information for all of the data sets. And so therefore, because it is literally the keys to the entire ZOS kingdom, it is an important critical resource. It's performance sensitive. The catalog address space has a couple of optimization mechanisms that you can use to make sure that the data in the catalog is cached, that it's shared across multiple systems, and in the most frequently accessed data is actually on the volume, in the VVDS, which we'll talk about, the VSAM volume data set, which is where most of the data actually resides. What actually resides in the sort of top half of the catalog, the VCS, is really just data set names and alias names. Most of the stuff that we need to access very often is down at the volume level. Catalogs are really, they enhance performance, they enhance the usability of a ZOS system, in that the catalogs can reside anywhere. The original implementation of catalogs in the 1960s, the catalog had to reside, catalogs for certain data sets had to reside on certain volumes, but modern catalogs, they're ordinary VSAM data sets, and so therefore they're subject to the ordinary VSAM restriction, which is the no catalog can exceed more than 123 extents on a volume, which normally is not a problem these days, although if the volume is highly volatile and chopped up in a little free space, you can run into extent issues when you begin taking many extents in a catalog. If there's a lot of catalog updates, they're addressable by key, and generally the key is the data set name. The one thing that really sort of is a restriction for catalogs is the basic catalog structure. The VCS cannot be multi-volume. And so because they're performance sensitive, they really, you have to keep an eye on them in terms of making sure that they're properly cached and properly shared. We'll talk about that. We can use IDCAMS as our primary tool to deal with catalogs if we have to create a catalog, or if we have to split a catalog because it's getting too many entries under one high-level qualifier. We can use IDCAMS to do that. We can merge them and reorganize them. And we can also back them up and restore them with IDCAMS via export and import, or via ordinary backup utilities. FDR, AVR, DFDSS will also deal with catalogs because they're really just VSAM data sets. Okay, so we have a couple of different types of catalogs that we deal with in ZOS systems. And back in the good old days when dinosaurs walked the earth, and I started my career, the 1960s and 70s, we didn't really have, we had catalogs, but they were called CVOLs, or catalogs that resided on what were called control volumes, and they had a name of syscatalog, and there was a hierarchical structure to them. There were pointers to various pieces of the catalog, but it was very volume oriented. The catalog for a particular high-level qualifier had to sit on the same volume as most of the data sets for that high-level qualifier, and the structure got rather complicated. So sometime around the 1970s, the early 70s really, well, mid-70s, IBM came up with the Integrated Catalog Facility, or ICF catalogs, which is really the only kind of catalog available today. The syscatalogs have gone away. And so we have really three different sorts of catalogs that one might find in a ZOS system. The first thing you'll have to find, of course, is the master catalog. And it's as we'll talk about, it's a VSAM key sequence data set, but it can reside on any volume. It need not reside on some particular volume. The master catalog is the one that's going to be probably hit most often, and so it should contain the minimum number of things that we need so in order for it to perform properly. So we have to have entries in the master catalog for system data sets. That is, where do the data sets on sys1 LPA live reside? Where do the data sets on sys1 link live reside? The other thing that we have within the master catalog are aliases or pointers or alias names, if you prefer, to other catalogs, to the user catalog. And then we have the user catalogs, which contain the data set records containing, each record containing a data set name and the data set location, the vol ser, and maybe some other information about the data set. There's no logical difference between a master catalog and a user catalog. The only way a master catalog becomes a master catalog is that it's identified by a ParmLive member at IPL as this is the master catalog. It could be the user catalog to another system because they're really identical, just ordinary VSAM data sets. The other is sort of a little bit different type of catalog. It's an ordinary catalog, but when you create it, you specify in IDCAMS defined catalog, you specify the volcat parameter, and it's the tape catalog, which is something different than the what's called the tape management catalog or the TMS catalog or the tape management system database. The tape catalog, or what's usually called the volcat catalog, because that's the parameter that you specify to create an IDCAMS defined catalog or defined catalog volcat. It's known as the volcat or the TCDB, the tape configuration database, and it's designed to hold the entries. It has two types of entries: one manual tape volumes, one for tape libraries, either a manual tape library or an automated tape library. Manual tape library isn't really manual these days, but it might be something like the Dell EMC DLM or the Optica ZBT, or an automated tape library like the IBM TS7700. So we have two types of entries in the catalog, tape catalog in the volcat. We have library entries and volume entries. So the tape catalog tells us about tape volumes. It doesn't tell us all the information we need to know about tapes. And it's something different from the tape management system, but it is required for these automated tape systems like the EMC DLM or the TS7700 to be able to mount their tapes, because they have to know what library those tapes reside in and which tapes exist. So we have three types of catalogs we might deal with then. The master catalog, the user catalog, which contains a minimal amount of information, system data sets and aliases, basically. The user catalog, which contains what we really are interested in, a data set name, a data set location, information about the data set, and then the tape catalogs, or the TCDB, or the single tape catalog. You can have more than one, but that's unusual. Okay, so where do we find things in the catalog? There has to be a search order if I have a hierarchy of catalogs or multiple catalogs. I have in the master catalog alias pointers to other catalogs. So I might have a high-level qualifier prod in my master catalog. I have a prod alias that points to a user catalog, which might be named anything, but it typically will have a high-level qualifier prod. And so I have an alias record usually in the master catalog that points to a user catalog. It could point directly to a data set name, and I can also have alias entries in the user catalog that are alias names or just additional names for data sets. And that's useful if I want to maintain the same sort of data set name for multiple releases of a product or something like that. But I have an alias record that points to a user catalog, typically, and it's typically a single high-level qualifier that points to that user catalog. You can enable something in the catalog address space. You can enable multi-level aliasing, which allows you to use more than one data set name qualifier to select the catalog. So if I set, for example, the alias level, multi-level alias, I turn on the multi-level alias facility, and I set the alias level to 1, then a data set named A.B.C, and this is the default, I will find in a user catalog with an alias of A. But if I set the alias level to 2, that is, I'm going to use 2 qualifiers to find a catalog, then A.B.C would reside in a catalog, user catalog, which is aliased to A.B. The multi-level alias facility is typically used where you've got a whole lot of data sets under a single qualifier, and you don't want to put them all in one catalog. So you want to split them, split what would otherwise be a very a catalog with a lot of data sets under the same qualifier, and therefore the catalogs may be beginning to get full. You might want to split that into 2 catalogs, and so therefore, but all these data sets have the same high-level qualifier, well, you might want to use 2 or 3 qualifiers to determine what catalog to go to. When the system, if I have a DD statement that specifies a data set name, when the system goes to look for that data set, it has to look for it using some sort of search order. Just as if I go through if I'm going into the library and I have a name for a book that I'm looking for, I have to look for it in some sort of search order if there are several places it might be. So the standard order of search for a catalog is to, first of all, see if someone said, hey, look in this catalog here. So typically on an IDCAMS job, you used to see stepcat DD statements that would tell you what catalog to look in. They're either totally deprecated or not even permitted anymore. You may see them every once in a while, but the stepcat DD used to tell you for a particular job what catalog to look in. You really don't see stepcat DDs anymore, or if you do, you should take them out and shoot them, because they sort of violate the principle that things should be simple. So we can have an explicitly specified catalog, and that's typically if I'm doing an IDCAMS list cat or an IDCAMS alter or something like that, and I want to alter or list an entry in a particular catalog, then I can specify the catalog parameter in my IDCAMS control statement. But if the catalog name isn't explicitly specified, then we go to the master catalog and see if there's an alias with that high-level qualifier, which will point us to a particular user catalog. Or if multi-level alias is turned on, it might point us to, again, to a particular user catalog, but maybe that user catalog is aliased to a 2 or 3 level set of qualifiers. Or if I can't find it in any of those, if I can't find it if I didn't specify a particular catalog, I can't find an alias for it either in the user master catalog or the user catalog, well then hopefully I'll find an entry in the master catalog. And if I don't find a data set using that search order, then I will probably get a catalog locate error and I won't be able to find the data set. Okay, so what's actually in the catalog? We can kind of ask 2 questions about that. What kind of entries are in the catalog? What kind of data sets are cataloged? And then what information do we keep about each data set? So since the catalog has to keep track of every data set on Earth, therefore we have all kinds of different entries in the catalog. There's maybe 10 or 15 different possible types of catalog entries, which are related to the types of data sets that reside in the catalog. So we'll have entries, of course, for VSAM data sets. This is a VSAM data set. Here's where it resides. This is a non-VSAM data set. These are the volumes on which the non-VSAM data set resides. We have alias entries, which are primarily used to say data sets with this high-level qualifier belong to this user catalog, or can be found in this user catalog. So an alias really is typically a pointer to user catalog, although it can point directly to a particular data set. We have entries for generation data groups and generation data sets, which are 2 different things. The generation data group tells us about all of the data sets having a particular naming convention. And the GDS, the generation data set, is one of those data sets that belong to a particular GDG or GDG base. And so those are, again, different types of entries in the catalog. And in the volcat, in the tape volcat, I might have entries for SMS tape libraries and SMS tape volumes. If the tapes are not SMS managed, I don't have entries for tape libraries or tape volumes, and I don't have a volcat. The volcats, the tape volume catalogs, are really only for SMS managed data sets. And in the master catalog, I have some other things. I have some entries for the system data sets because I always wanted to have those available, page spaces, things like that. So we have in the catalog entries for any kind of data set we might imagine. What do we keep in the catalog? Well, we keep the vol seers primarily because that's what we're really interested in. I can't open a data set, I can't write to a data set unless I know its name and where it resides, because if I'm going to write to that data set, I need to know what volume to write to. What other kind of information is kept in the catalog? Class names, VSAM cluster names, and its associated components, because the VSAM data sets are a multi-part entity, and therefore I've got to have something, a record in the catalog that relates the cluster name to the component names. I've got to have, my data set name is steve.vsam.cluster. Somewhere I've got to know where steve.vsam.data and steve.vsam.index and the alternate index and so on all reside. So that information is all kept in the catalog. In fact, it's all kept in one place in the catalog called the sphere record, which we'll talk about. But the sphere record relates a whole bunch of different components of a data set together. A whole bunch of other information in the catalog. And when we talk about the catalog, we're really talking here about not only the BCS part of the catalog, which we'll talk about, but also the VBDS, that part of the catalog that's on the volume as well as just the catalog itself. Encryption key labels, file sequence numbers for tape data sets, for example, because tape data sets, as opposed to tape volumes or libraries, are cataloged in the catalog just like any other non-VSAM data set. And there's much more, many more things in the catalog. And when we go to get that information from the catalog, we need to know what fields we want. Do I want the encryption key label? Do I want the file sequence number? Do I want the data set name or the data class name? There is a field name dictionary that will tell me what character string I need to use to get the file sequence number or to get the data class when I request it from the catalog. So what's not in the catalog? Well, the DCB characteristics for a data set, the data set type, the DSN type large or extended format, the space information, the creation date, the expiration date. Where does all that stuff reside, particularly the extent locations for non-VSAM data sets? That's not in the catalog. That exists on the VTOM. The volume table of contents contains volume level information. Now, some of the reason I say mostly here, as far as what's not in the catalog, is some of that, in fact, is in the catalog. It's in the VVDS on the volume. But really, the catalog itself, the basic catalog structure, mostly contains the data set name, the vol.sir, and some association information, what other components of this data set are related to it. What has to be cataloged, SMS managed data sets have to be cataloged. When SMS came out in 1979, that was the golden rule that thou shalt catalog all data sets because IBM finally decided we're just not going to deal with uncatalogued data sets anymore. In order for the system to manage itself, which is what system managed storage was supposed to be, in order to have that automation where the system manages itself, the data sets have to be cataloged. We have to know where they live. VSAM data sets obviously also have to be cataloged because we have to have a catalog sphere record, a catalog entry that says, given this cluster name, where do the components reside and what components exist? Is there an alternate index? Is there a path? We need to put that all under one umbrella in a single record in the catalog, and so VSAM data sets must be cataloged. Tape data sets may or may not be cataloged. Tape data sets are one of these sort of exceptions to the rule where sometimes you have homegrown systems that will manage their own tape data, but for the most part, tape data sets are like any other non-VSAM data set, have to be cataloged. There are still probably one or two applications out there that deal with uncatalogued data sets where they maintain their own sort of catalog or they maintain their own metadata about them, but there are not many left. Back some years ago, I was at a site that had dealt with a lot of uncatalogued data sets, and when I asked how they did that, they pointed me to a very large rack with a whole bunch of binders on it with papers in them where people wrote down what the data set names were and where they resided, and somehow this worked, at least for their installation, but it's not very practical in a large modern data center. So the catalog contains entries for all kinds of data sets. It contains information that's primarily location information, but there's certain information that's not there, and that's over in the VTOM. We've sort of mentioned the tape libraries. I won't go too much more detail into the tape data and metadata, but there are three repositories where tape volume information is kept. One is in the device, whether it's an IBM TS7700 or an optical ZBT, whatever it might be. The device itself has to know what volumes reside in it. So there's an inventory in the device that says these are the volumes that live in this device. That information is duplicated in the tape configuration database, the volcat, which contains volume and library information. And so it says for every volume, this volume lives in this device, whatever I've named it, and the library information. These are the names of the devices that exist. But it doesn't tell us neither the device library inventory nor the TCDB, the volcat, tells us anything about the individual data sets on the volume. So the individual, on any given tape volume, the individual data sets are cataloged in the ZOS catalog. Just like ordinary tape, any ordinary tape data set is a non-VSAM data set, and it's cataloged in the ZOS catalog. At the same time, it is also cataloged by the tape management system, because the tape management system has to keep track of where all the volumes are, what libraries they're in, what data sets exist on the volume, and what file sequence numbers they have, and when they're going to expire. And so we have a lot of information that's duplicated here because this has grown up over a long period of time. And all of these, particularly the tape management system, and actually all of these have to keep track of whether a tape is scratch or non-scratch, and when that volume expires, possibly the volume's SMS attributes. And so there's a lot of information in the tape catalog, the TCDB, that's required, but it's only one part of the whole system that keeps track of tapes, and that includes the tape management system and the device itself. Okay, so let's go back and talk a little bit about the catalog structure and how we go and find data sets, and then we'll talk a little bit about how we get information out of the catalog to find out what we want to know. Where does the data set live? What does it look like? Okay, so the catalog structure you can think of in really two parts plus the VTOC. The VTOC is not really part of the catalog, but it contains important information about the data set, about any given data set. So the BCS is the basic catalog structure is usually what people are talking about when they say it's in the catalog. The catalog technically is both the BCS, the basic catalog structure, which is a VSAM key sequence data set, plus one or more VVDSs, the VSAM volume data sets, which are entry sequence VSAM data sets that live on each volume in the system. So each DASD volume in the system, each this volume, has a data set on it called sys1.vvds.volume serial number. It's not, I don't believe it's called vvols here. It's just called sys1.vvds.tso001, tso002, whatever the vols here might be. That resides on every volume in the system that has either VSAM data sets on it, or nowadays, it might not have any VSAM data sets, but has SMS managed data sets on it. You need a VVDS on that volume. So the BCS is a structure that it's just a variable length record KSDS where the key is the data set name plus an additional byte in case the record extends, in case we have to use multiple records for a data set. The VVDS tells us about the data sets on a particular volume. And then the VTOC tells us still more detail about the data sets on a particular volume. The VTOC consists of 140 byte records called DSCVs, data set control blocks, with the 44 byte key of the data set name. So we have sort of two keyed structures here, the BCS and the VTOC, and then the VVDS, which tells us about, as we said, VSAM data sets and the SMS managed data sets on any given volume. But so usually when we're talking about the catalog, we're talking about the BCS, but we might be talking about the BCS and the VVDS because the two of them are related. Anything that's in the BCS will have a VVDS entry for a given data set and vice versa. Okay, so the BCS tells us the basic information we really need. Where does the data set reside? What vol sphere does it reside on? There are some other fields in there in the records in the BCS that tell us more information about the data set. The DSCV TTR field is actually used to tell us where the data sets format 1 DSCV is on the where the data sets format 1 DSCV is in the volume, or it's also used by FDR. There are a whole bunch of individual cells within the records of the BCS. There are cells for who owns it, for RACF security, for most importantly for the associations. What other records in the BCS are related to this data set? So for a VSAM data set, there's an association cell that says there are components that are related to this data set. There's an alternate index. Or for GDG, there are generation data sets related to this GDG base. Also the SMS classes and so on, they're all in what are called cells within any given particular VCS record. But what's not in there are what extents does the data set reside on? What are the VSAM statistics for a data set? You know, how many IOs were done to it, how often was it open for read, write, all that stuff that you get in the IDCAMS listcat doesn't reside in the VCS. That resides in the VVDS and the VTOC. And the first entry, the first cell in every record in the VCS is always the entry type. And the entry type is a 1-byte field that says, this is a record for a VSAM data set or a non-VSAM data set or a GDG. And that's actually, and the entry type is important when we go and say, I want to retrieve these entries from the catalog. And so the data set records are typically called entries. And that is important when we're going to retrieve information from the catalog. I want to retrieve a catalog entry of this particular name and an entry of this particular type. So as we said, there are 2 types of records. There are sphere records for things with multiple associations, VSAM clusters, GDGs, a few other things like that. And then everything else is a non-sphere record, just an ordinary record. And so we're typically talking about these records residing in the user catalog, but they might reside in the master catalog if they're for system data set, or they're an alias record to say this data sets of this high-level qualifier can be found in this user catalog, AB1 or AB2 or AB3. Okay, and then we've got the VVDS, which has to be put on the volume. And it's the VSAM volume data set. When it came out, it was to keep track of VSAM data sets on the volume. But nowadays it's a misnomer because when SMS came out, it also, we needed to have some place to keep the class names, the data class, the management class, the storage class associated with the data set. And so those got put, so the VVDS is now required on virtually every volume in the system. Unless it's got no VSAM and no SMS managed data, it requires a VVDS. And it's named sys1.vvds.v volume serial number. We can create it either explicitly with an IDCAMS define, like this, or it will be created implicitly if there's no VVDS on the volume. The first time you allocate an SMS managed data set or a VSAM data set on a volume, the system will go and create the VVDS for you. And it creates it of a size that is specified in the sys1 farmlet number. So there are 3 types of records in the VVDS, only 2 of which are important to us. One is the control record. There's a couple of different types of control records called VVCRs, and they tell us what VCSs belong to this VVDS, and what VVDSs point to this, what VCSs are pointed to by this VVDS. So the names of the associated catalogs. And then there's a self-describing record, but where the data set records are what is really of importance. And there are 2 types. It used to be just VVRs, VSAM volume records, that tell us for any VSAM cluster what its components are and where on the volume those components reside. That is, what extents, what cylinder and track number do the extents of the data set reside on this volume. Also, things like the statistics. Is it an extended format data set? Is it a relative record or a key sequence data set, or is it an alternate index? All of that VSAM information, what its SMS classes are all kept in a VSAM sphere record. The non-VSAM records are those for non-VSAM data sets. There's not too much in them. In the VVDS for a non-VSAM record, an NVR, it basically contains the data set name and the SMS class names, so that when I back up or restore a data set, I don't really have to go to the catalog very much. I can know from the VVDS what the class names are for this data set, and that's what's used by SMS to keep track of how should I deal with this data set, when should I back it up, how long should I keep the backups, things like that. So we said there's an entry type for each catalog record. And so in the VCS, there are a whole bunch of different types of records here. I said non-VSAM records. This is These are actually VSAM and non-VSAM records, but they're records that are in the BCS. So these two headers really should read BCS records and VVDS records, not non-VSAM, VSAM. So the BCS records could be type A, which you would think is alias, but it's not. That's a type X. An A record is for a non-VSAM data set. A B is for a GDG. A C is for a cluster, and a D is for a data component, and the highest for index component. So each record in the catalog, which will be of a varying length, but will always have a 44-byte key, is a record that has an entry type. This is the type of entry we're talking about here: an alternate index, a generation data set. And in the VVDS, there are two types of records: a VSAM, a VVR, or an NVR. And there is a primary or a secondary, but usually the secondary VVR is just for things that continue to another volume. So there's really just a VSAM record and a non-VSAM record for any given data set. And then there are some control records. Within each record, there's a whole bunch of cells, and within the cells, of course, there are subcells. So things can get within the catalog, if you really dive into the catalog in great depth, or if you're using some catalog management product that is designed to debug catalog problems, that it can get very involved, because within each cell, within each record, whether it's a VSAM record or a non-VSAM record, a type A record or a C record or D record, there's a header cell, which will tell you the record type. And then there might be, for example, for VSAM, there's a base cluster name cell, there's a data set information cell. Is this a key sequence data set or an entry sequence data set? There's an SMS subcell within the data set information cell. It says these are the classes that belong to it. The AMDSB cell, which gives you a whole bunch of VSAM statistics. The volume cell, which tells us what volume we reside on. So we don't really need to know the details of the catalog record types, but it's important to understand there are different types. And when I want a particular type of record back, I need to know whether I want a B record because I want the GDG information, or I want a D record because I want the data set, the data component information. Okay, so how do we get this information out of the catalog? What we're trying to find out for a data set in the catalog is, what does the data set look like? Well, we can use TSO listDS command or ISPF 3.4, and that will give us the basic information we need. If I do a TSO listDS or go to ISPF 3.4, it will give me the VolSeer information. And in fact, it'll actually go out to the VTOC as well and give me the DCB information, but very basic information for a particular data set. If I want more detailed information, well, from the catalog, the primary tool to get information out of the catalog is program IDCAMS and the listcat control statement within IDCAMS, which will return the catalog entry, or possibly more than one entry, depending on whether you mask it, but the masking available in IDCAMS is kind of limited. It will obtain the catalog entry for a particular selection. So typically, you're going to select an entry name. I want a data set I want information about the data set with this name, or possibly the data set with this high-level qualifier or a set of high-level qualifiers. And I want information for this entry type. So name and type are typically what we're looking for. I want information about the cluster, or maybe just the data component or the alias component. But we can get information from more than one entry, but it's kind of limited in terms of its masking. And that information is always returned in a fixed format. So we have a little bit of filtering that we can do on the output. We can say, I'm interested just in the names, or just in this, the allocation or the VolSeer information. If I want to post-process the output, and a lot of installations have REXX execs that will go and post-process the output of a listcat command, there is an output operand you can specify on IDCAMS listcat to say, take the sysprint, put it somewhere into a data set for later processing. So just a couple of examples here, the types of information we might have. What IDCAMS really does is just dumps the information out of the BCS and the VVDS. And so if I'm looking for this cluster, sjp.sms.clus, it tells me what user catalog it's in, and then it divides the it gets me information back from the cells in the record, in the C record and the D record for this data set. So there's a history, who's the data set owner, what's the creation and expiration date, that's in the primary cell for the C record. The SMS data comes from the SMS subcell. What's the storage class? What's the data class? There's a couple of other attributes. Is it extended attribute? Is it backup well open? Those are also reside in the SMS subcell. There's an RLS data component for record level sharing. If when I created the data set, I said, I want it to be a record level sharing data set, here's the log file name I specified, should it be quiesced, and so on. There's a whole bunch of other things, but you'll notice each one of these has a little section that's saying this is coming from a particular cell or subcell from a record for, from the entry for this data set. For the non-VSAM case here, I'm looking, for example, at a tape data set. The number of cells is a lot less. There's a little bit of history information, which is when was it created, when's it expired. The encryption key label if the data set was encrypted, and the vol seer, device type, and file sequence number. The file sequence number is important for tape because I might put multiple data sets on a single tape, but you'll notice that it's a lot shorter. There is no attributes section as there is, which is, you can't really see the cluster here, but there's a lot more data in the cluster here because it's a sphere record that might have alternate index components and path components and a whole bunch of other things. The non-VSAM records are a lot smaller. Okay. So how do I get information out of the catalog besides listcat? Well, there's a couple of different ways of doing that. One is that a lot of people aren't really familiar with is ISMF. We can go to ISMF option 1. There are two options in ISMF that are really designed for end users more than storage administrators, or at least as much as storage administrators, and that's option 1 and 2, data set and volume. So I can go to ISMF option 1, and there's lots of filtering I can do to say, give me all the data sets meeting this naming convention of this size with these attributes. So if you have access to ISMF, you can get some information from the catalog, and in fact from the VTAC and BBS as well. And there's a lot of filtering and reporting you can actually do under ISMF. Programmatically, there are a couple of TSO service routines that you can call. One is IKJ EHCIR, CIR being for catalog information routine, which returns a list of data set names and volume serial numbers by high-level qualifier, really. So there's not a lot of masking there. If you're doing a lot of ISPF work, there is a TSO service routine you can call. We give you a list of data set names matching some mask and return it in an ISPF table, which is kind of nice if you're doing ISPF programming. But the primary thing that gets information from the catalog, and it's used in fact by listcat, is SVC 26. This is the catalog locate SVC. Locate saying, I want to locate the data set. So SVC 26 is the locate SVC. And in fact, that's actually under the covers what IDCAMS uses. It ultimately invokes SVC 26. There are two flavors of SVC 26, one of which is documented, the other which is not. SVC 26 locate and cam list macros, which you can find in the IBM manuals, and here's a little example, will return, and it has to be coded in assembler, obviously, will return for a given data set, which you specify the name in the what's called the cam list or the catalog access macro list. You can specify the data set name in the cam list and issue a locate macro, which will generate SVC 26, and it will return you a list of volumes. That's all there is to it. A catalog locate with the cam list returns a list of volumes. Catalog locate with what's called a CTGPL or a catalog parameter list will return all kinds of detailed information for very large numbers of entries with all kinds of masking. It can do, you can actually invoke SVC 26 to do a define or alter or delete or some other authorized function, and it's unfortunately undocumented. It's used by ISVs. It's been used for a very long time, but it's got a very large and complex parameter list. So what people really would like is to be able to get any information programmatically that they want from the catalog And so what IBM finally broke down a few years back and gave us the catalog search interface, which is really just a simplified version of SVC 26, or one of the SVC 26 functions called generic filter locate. And the program is named IGGCSI00. You can call it from REXX or from assembler, and there's a parameter list which points to a couple of things, but what you've got to give it is an entry name, that is the filter key, and then the field names you want returned. So I can say I want the entry name, I want the entry type, so this is the name, return me, or for this mask, dataset name mask, return me all the entries that match it of type A or type D or type C. And what other information do I want? Maybe I want the expiration date, maybe I want the GDG limit value if it's a GDG, maybe I want the high used RBA. There's a whole list of field names. There's a field name dictionary you can look at to say I want the key label, I want the SMS information, that is the data class, management class, storage class returned. And this information is returned into a work area, and the work area, the amount of information returned is going to vary depending on what you asked for, how many field names you asked for, how many dataset names you asked for with the dataset name mask. But the catalog search interface will go out and return information about a whole bunch of datasets, and it will return from the catalog any information you asked for by field name. So it's very simple to use, particularly in assembler, but if you're using REXX, it's equally easy in REXX. You can use whatever entry name masking you want, a full wildcard name that will return multiple entries per call. So if I want the information about 10 or 100 or 1,000 data sets, I can get that back with one call, or if necessary, I can resume it if I didn't give it enough work area. But the trick is I need to know what dataset name mask I'm looking for and what field names I'm looking for. And the catalog search interface will return me all of that information in a formatted way that I can deal with it programmatically. So there are some examples that IBM provides that make it pretty easy to use catalog search interface. They're in Sys1 Samplide. There's a couple of assembler examples. The one that's really of interest is IGG CSI VS, which says find me all the data set name, well, actually, all of these are interesting. The one that's actually of interest, IGG CSI LC, lists the entry types in the specified catalog. So there's some assembler examples. What's perhaps more useful is a REXX example, IGG CSI REXX, which is a REXX routine that invokes the catalog search interface and returns the entry name, the entry type, that is it a data component, index component, non-VSAM, and the vol CR4 specified dataset name filter. It's very easy to change to get other fields. And there's another REXX exec, which is actually an IBM FTP site that you can go to, where you can take that REXX exec and say, give it a name mask and the field names that you're interested in. In this case, I'm interested in return me the volume serial number and the data class, storage class, management class, key label, encryption key label, and maybe the creation date. There's a couple of different flavors of creation date. So you can go to this FTP site and get this example, again, of calling the catalog search interface. The other way to get information out of the catalog is a REXX list DSI function. It's a TSO function. So you code it in REXX as some variable equal list DSI and the dataset name you want. And it will return information in something like 40 or 42 REXX variables. For VSAM clusters, it doesn't return too much information. It doesn't return any information with tape or GDG, but for non-VSAM data sets, it will tell you everything you could possibly want to know about the data set, and it returns it in these REXX variables, sysds name, sysvolume, sysunit. I actually have those twice there. There's some optional parameters about do I want to recall the data set, do I want directory information, and so on. So list DSI is a REXX TSO function that is really useful, and if it fails, of course, you can return the reason code and the messages from REXX will be returned to the REXX exec. Okay, There are some IDCAMS commands that you should probably run to make sure that the catalog is, your catalogs are healthy and not broken. The diagnose command will compare a VVDS to its BCS and make sure they're synchronized properly. The examine command will make sure that the BCS data is valid. The BCS data and index components are valid. You might want to run verify if there's been a system crash. So there's a whole bunch of IDCAMS commands that are important that we really don't really quite have time to talk about, but we can perhaps in a future webinar talk maybe about export and import of catalogs, how to back up a catalog, how to restore a catalog, because it can be a little bit complicated. There is a facility called the ICF Catalog Recovery Utility, ICFRU, which is documented in managing catalogs, which takes the SMF records, and there are a bunch of different SMF records that are cut for every access to a catalog to create data sets, delete data sets, alter them. We can take those SMF records and use those as input to the ICF Catalog Recovery Utility to rebuild the catalog that's been damaged. And finally, there are some sys1 ParmLib configuration members that have to do with catalogs. IgG cat00 is the primary one. The load and syscat members tell us which catalog is the master catalog. But the IgG cat members tell us all kinds of information about, am I allowed to use extended GDGs? Do I get warnings when a catalog reaches a certain number of extents? Things like that. And so I can override or change the values in IgG cat00 with a modify command to the catalog address space. And so this is a really useful and interesting command, modify catalog. You can specify modify catalog report, and it will tell you all about the status of the catalog address space. What's the default size of any VVDSs I have to create? What's my maximum GDG limit, and so on. So finally, all of this is documented mostly in DFSMS managing catalogs. Also, access method services commands for the IDCAMS commands. If you're really into assembler programming, take a look at DFSMS DFP Advanced Services Guide, and that's really useful for, again, getting information out of catalogs. So we have just a couple of minutes left, but I do want to mention next month's webinar in December. We'll talk about expiration. Expiration, as part of the dataset lifecycle, datasets are created, they're born, they live for a while, and eventually they have to die. And what happens to them before they die? Do they get archived? When they get archived, how long do they live on various levels, and when ultimately are datasets deleted? And so at this point, we've got right up the hour, but I think we've got time for a few questions, if there are any questions. I'll turn it back over to you, Ray, and open it up for any questions.
All right, thanks, Steve. At the moment, no questions in chat. Again, we apologize for the technical difficulties we had earlier at the beginning of the webinar. But yeah, if you do have any questions, you can either drop them in the chat right now or send them to us. The sync sort, sorry, the support, there we go, support@precisely.com. The support personnel can maybe answer your questions, or they can route it over to us. We also do have a community out on the Precisely webpage. You can put questions and other things there. All right.
And I should mention that everybody will get a copy of this. I hope we'll get a copy of the slides. They'll also be available on the Precisely website. And we encourage you to send questions if you have questions or problems with the data center in general. We're always looking to put together new products or do something with our existing products that you may already have to solve your problems. And so particularly for those users who have ACC allocation, SyncSort, what's now SyncSort Allocation Control Center. We have added some capabilities to it that extend its reach quite a bit. And if you're interested in those, drop us a line and we'll be glad to talk about SyncSort ACC or SRS or any other topic that you want to talk about.
Actually, we have had a couple questions pop in here. One is there, do people still use the GDG LADAT for the old generation?
I'm sorry, the GDG LAT?
LADAT. LADAT.
I'm sort of drawing a blank on that. I'm not exactly sure. I'm guessing that that's a field name entry or dictionary entry. So I'm not sure on that. You might send me a separate question on that at steve.pryor@precisely.com, because I'm not quite sure what the question is. Do people, if it's, because IBM has, some years ago, with the later releases of ZOS, has increased the generation limit from 255 to 999, but you really have to redefine the GDG to do that. So okay. I'm not sure exactly which field that would be.
Clarification came in. That's the last date access. Or last access date.
I'm not sure. That's not what I'm familiar with. And so I might need to take a little closer look at that. If there is a last date accessed field in the catalog for GDGs for a GDS data set, I'm not familiar with it. That may be a CA disk value. CA disk used to keep track of things like that. So I am not familiar with that one, I'm afraid. I will take a look and try and get back to it. And if you want to send me a note, I'll take a closer look at that. I have to admit I'm not familiar with that one.
Okay. And then we're a little bit past here, but we did have one other question. This is explain what I call the catalog back pointer in the VVR. IDCAM's print of VBDS shows dataset name and then catalog in which that VSAM dataset is supposed to be cataloged. Is that the, I guess that's, is that a correct understanding?
The VBDS, read that again?
IDCAM's print of the VBDS shows a dataset name and then the catalog in which the VSAM dataset is supposed to be cataloged. I guess it's a field in the VVR?
Yes.
Okay.
Yeah, and so if you want to delete that VVR, you actually have to, in the delete VVR, you have to specify the catalog name in which that data set was cataloged. And the only way you know is to print the VVR. So yes, when you, for a VSAM data set, if it's been deleted from the catalog, but the VVR is still there, you'll have trouble recreating that data set unless you get rid of that VVR. But to delete that VVR, you have to specify the catalog name, which, you know, and sometimes those catalogs are long gone, but you still have to specify the name if that's the question. I may not be answering you quite correctly.
Okay.
Deleting VVRs and deleting NVRs is sometimes a little bit problematic because it does require the catalog name usually.
Okay. I guess the question was more, is the term catalog back pointer correct or a valid term?
It's not one I've run across, but it certainly seems valid to me, yeah. It's the pointer to the catalog. I'm not sure that it's a back pointer, but it's, I mean, it does point back to BCS. So yes, I guess it is a back pointer. But I'm not sure that it's an official term, but it certainly seems reasonable.
Thanks, everybody. And again, we will send out a link to the recording later, and then join us for the next one.
Thank you, everyone. We'll see you next month.